Okay, so this is your video on atomic structure. You should have seen the Bill Nye video in class, but if you were absent, here's the link to that. So we went over what atoms were in the last part of the unit, the history portion, and atoms are the smallest part of an element that still allows it to keep its identity. Democritus did say that everything was made of atomos, which in Greek means indivisible. And on your paper where it says subatomic particles, parts of an atom, we're going to go in this order: electron, proton, and neutron. So there are parts that make up an atom. Electrons have a negative charge, and they're found in the electron cloud or outside of the nucleus. Protons have a positive charge. They start with P, and they identify the atom. Quarks are also building blocks of protons. Protons are found in the nucleus of an atom. Neutrons have a neutral charge. You'll notice that I've highlighted the first 5 letters because sometimes people get neutron confused with the word negative. It should not be a negative charge. And quarks are also the building blocks of these as well. So quarks are the building blocks of both protons and neutrons, all the things found in the nucleus of an atom. So just to give you a little bit of an analogy about the atom, subatomic particles, which include electrons, protons, and neutrons, and then also the building blocks of those, quarks. Think of yourself, an individual, as having an identity or a personality, and we'll consider that an atom. Okay, there are things that build you, or that you are made of. For instance, your organs are parts of you, but they don't have like a personality or an identity. So we would consider them the subatomic particles. They build you, but they don't have an identity. And then quarks, which are building blocks of protons and neutrons, we'll consider these cells. Okay? And they would make up your organs. At the bottom, there is a model of the atom. Please label it with protons, neutrons, and electrons. You can pause me and come back when you're ready. So on your packet, if you flip the page, you'll notice that this table is there, and there's some things to fill in. Most of this stuff you should already know from 5th grade. The electron has a negative charge. It's found outside of the nucleus in what we call the electron cloud. And you'll notice it has a mass of basically 0. That's how scientists look at it. It has a mass of 0. And the units for the mass in an atom are the atomic mass units. And the reason we use AMU instead of things like grams is because they are so tiny. A proton is found in the nucleus, and it is positive. It has a mass of basically 1. And a neutron, also found in the nucleus, has no charge. It's neutral, and also has a mass of basically 1. One of the conclusions of Rutherford's gold foil experiment was that all of an atom's mass can be found in the nucleus because it's dense, so there's lots of stuff in a very small space. And you'll notice that the 2 things found in the nucleus, the proton and the neutron, have a mass, whereas the electron has such a small mass that scientists ignore it. It doesn't really count. Okay, so now we're going to go to mass number, and because the mass of the electron is so small, we ignore it, like I said before. And to find the mass number, we're going to take the protons plus the neutrons. So the number of protons in the atom plus the number of neutrons in the atom. It is always going to be a whole number, and it is the mass of that exact atom, because there's going to be other atoms that you find that are the same element, but they're going to have a different mass. Excuse me. So here's your first practice. Fluorine. If you have 9 protons and 10 neutrons, since they both have a mass of 1, all you have to do is add those 2 numbers together and you'll get a mass of 19. Your next practice one is for carbon. It says it has 6 protons, 6 neutrons, and 6 electrons. Once again, electrons don't matter when we're talking about mass because they don't have a mass. Scientists ignore it because it's so teeny tiny. So take 6 plus 6, 6 protons plus 6 neutrons, and you will get 12. So the atomic number of an atom is the number of protons in the nucleus, and that one is the number 9, so that's going to be the same as the protons in the nucleus. So if you have 6 protons, your atomic number is 6. All right, so if you flip over, we'll go to isotopes. Atoms of the same element sometimes have different masses. These are called isotopes. Since an atom's mass is all found in the nucleus, scientists can determine what isotope of an element is present by adding the protons and neutrons. We call this the mass number. And we just talked about atomic number. It's equal to the number of protons. And since the protons identify the atom, so does the atomic number. And when we get to the periodic table, we will talk about where to find the atomic number. So we just talked about mass and isotopes and how protons and neutrons figure the mass of an atom. But mass doesn't really have any say in how an element is going to react with another element. It really depends on the charge of an atom. So if we go to that third bullet under ions, that's where you'll be writing the highlighted thing written on the screen. And just to review, protons are positive, electrons are negative, and neutrons carry no charge. So atoms that have a charge are called ions. When the number of protons and electrons are equal, the atom is considered electrically neutral. So they basically cancel each other out. If you have 3 electrons and 3 protons, you have a neutral atom. They all have a buddy. If you have more protons than electrons, the atom is positive. It's going to be called a cation. Atoms can also have more electrons than protons, and when this is the case, the atom has a net negative charge, and these are called anions. I'll give you a way to remember this when we get into class on Friday. Okay, so we're going to practice now that your notes are completed. So if you have 9 protons and 10 electrons, what kind of ion is it? So you can either subtract the electrons from the protons to find the charge, or the way I like to do it, I say, which one has more? There are more electrons. How many more? 1. So there's 1 more electron. What charge does an electron have? It's negative. So your charge of that fluorine atom is -1 because you have 1 more negative than you have positives. So there's 1 negative guy without a buddy. Okay, so if you have 12 protons and 10 electrons, there are 2 guys without a buddy. Okay, and those 2 guys happen to be positive. So therefore, it's going to be a cation, and its charge is going to be +2. Because there are 2 more positives than there are negatives. So just to review, the mass number is protons plus neutrons, and it is just for that atom. The atomic number is the number of protons in the nucleus, so they're always going to be the same. Also, both of those numbers, since they're the same, identify the element. If you change the atomic number or the number of protons, you are changing the element. And a positively charged ion is a cation, and a negatively charged one is called an anion. So with a cation, you're going to have more protons. With an anion, you're going to have more electrons. And atoms can exist in nature as different isotopes, which means they have different masses, but they would be the same element. So they're going to have a different number of neutrons. Thanks for listening. See you on Friday.